Hi, I'm Rehan Durrani. I'm a student at the Rise Lab. I work on prediction serving with both Joey and Jan, deja vu, I suppose. In the rest of the section, I'm going to walk you guys through what we think is the final piece of the prediction serving stack, as well as demo a really cool system we've been working on. So look forward to that. All right, before I start, let me give a quick recap of what Simon talked about. So in the first half of the session, Simon showed us how to expose our models to the outside world using prediction serving, specifically the RayServe framework. But let's take a step back. Where do our models come from? What happens before prediction serving? Right? Are we building and training our own models? Or more likely, are we git cloning pre-trained models? We'd like to make a bold prediction. ModelZoos are the future. ModelZoos are repositories of pre-trained models, and the world is moving towards them. To list a few very popular examples, you have ModelZoo.co, PyTorch's Torch Hub and Torch Vision, Onyx ModelZoo, and Hugging Face Transformers. And if you don't believe me, just ask Apple. Recently, Apple has been developing their new ML platform, Overton, that uses pre-trained transformers for internal ML development. In the process, they ended up downloading 45 terabytes worth of data off of Hugging Face's servers. So, let's say you're Apple. You've downloaded your 45 terabytes worth of data, embarrassed yourself on Twitter, and you're ready to get down to the serious business of making predictions. What does that look like? We start with step one. Download your model data, hopefully not DDoSing the server this time. It's important to know at this point that you're oftentimes downloading hundreds of megabytes worth of model data to operate on a few megabytes of query data, so it's not very efficient. The next step is to wrangle your Conda and Python environments and build and install your dependencies. Not a very hard task, but definitely a tedious one. Lastly, you're modifying your data format to fit your model. So this means that you're writing pre- and post-processing functions for your model. Now you can get down to the business of making predictions. In and of itself, this pipeline isn't very hard. I'm sure that all of us, with a little bit of time and a whole lot of Stack Overflow, can get this done. But here's the thing. It doesn't scale. Imagine doing this thousands of times, every single time a new model comes out. That's why we decided to build a new system, ModelZoo Alive. ModelZoo Alive is a platform for sharing and discovering new models. When designing it, we had 3 goals in mind. The first was to make it easy to discover and share new models. The second was to build a programmatic API that could rigorously query and test models. And the third was to present a uniform interface for model evaluation. But rather than tell you about it, how about I show you? So we're actually going to start a demo. Whoops, I'm on a GitHub page. Okay, so this is our UI, ModelZoo Alive. Oh, should I zoom in? Can people read this? Not really? All right, let's zoom in then. All right, okay, so when we go to the UI, we see 3 things. The first is the models. So we can see a bunch of different models. We have like ImageNet, this should say ResNet 50, OpenAI, GPT-2, XLNet, a couple different models. We can also see some metrics, right? So for ImageNet, we have like our top 5 error. For our GPT-2 model, Winograd schema, challenge accuracy, etc. Right? The third thing we can see is metadata, and this is really important for model provenance. Metadata can tell us things like who made this model, what tasks did they have in mind, what data did they train on, what paper is written in. So it's really important for us to get a feel for like where the models are coming from and who's making them, right? So let's try it out. Does anyone have a suggestion for a model we should try? All right, seeing as we're all a little reticent, Simon, him, faster RCNN. Thank you. Totally not scripted, am I right? Okay, so it's at this point of the talk that my cat is actually going to make a cameo. He does so every single time I do a talk. This is him. He's begging for some ice cream. So we're going to take this URL, which points to an image, and we're going to pass it in as the input to our model. Right? So I run the model. It shows the image of my cat, and it draws some bounding boxes. So we're going to zoom in a bit. And we see that it does pretty well. So it recognizes that my cat is, in fact, a cat, and it recognizes that this tub of ice cream is a bowl. So that's pretty good, right? This is a great way to get visual acuity of our models. Sometimes, if you're doing just a single query, it can be a little frightening to be confronted by a huge wall of code, right? So this is a great way to take a look at each model and get sort of a feel for what the input and output are, as well as how our model is going to perform. I'll do a couple more examples. I don't know if you have any history buffs here, but these are some historical examples. So GPT-2 is a generative model for text made by the people at OpenAI. I'm sure most of, not all of us, are familiar with President Reagan's famous words in front of the wall. So let's see how GPT-2 would have fared in his shoes. So I'm going to copy paste his little bit of a speech just to give it some context so no one accuses me of cheating. All right. Okay. Thank you. Mr. Gorbachev, Mr. Gorbachev, thank you. Mr. Gorbachev, thank you, Mr. Chairman, the president of the... All right, maybe a little derivative, but, that's what our model says. Let's try one more example. Do you have any history buffs? Just anyone who's really interested in history? Yeah? All right, okay, that's, that makes 3 of us then. So I don't know if you guys know about the War of 1812, but I've actually found it a really interesting war to study. So let's see what ExcelNet thinks about it. War of 1812. All right. The Russian Revolution of 1917. The Russian Revolution of 1917 was caused by the Russian Revolution of 1915. All right, we can try again. Sure, it is generative, so it's going to give me a different answer every time. A lot of things. This is not the end of the story. Right, okay. I mean, technically true, it was caused by a lot of things, and it was not the end of the story, as we're all here today. So I'd say a pretty excellent response on the whole. Thank you to the 5 people who laughed. All right. So now let's talk about our second goal, our programmatic API, right? So ModelZoo actually consists of, I'd say, 3 main components. 2 main components. The first is the UI. That's the part we just saw, and it gives us visual acuity about models. The second is our programmatic API, right? This is composed of 3 subparts. The first is our gRPC server, which handles protobuf messages. The second is a reverse proxy, written in Go as well, that proxies curl requests to the gRPC server. And the third is our Python API. We don't actually have a demo released, but if you'd like to follow along, you can on the Jupyter notebooks that RiseCamp provides you. Just go ahead and install, do pip install ModelZoo. Surprisingly, we were able to get the package name. All right, so I'm gonna start off by importing ModelZoo connection from the ModelZoo API. This is the main class that's gonna manage our connection to the gRPC server. Oh, zoom in, sorry. I'm being told to zoom in. Okay, yeah, that's readable. All right, so I'm gonna import ModelZoo connection. Right? Now we need to connect to our ModelZoo client. So we have our gRPC server running on our server on port 9000. So I'm going to connect. And let's take a look at all of our models. Okay, all right. So we don't see all of our models because IPython cuts the display of large data frames. But we do see some of the models that we have on our UI. And we can also see all of our metadata. So again, a really interesting way to take a look at the different models that we have as well as the different data. Let's try a query, the same that we did, well, a similar query to the one that we did on the UI, just to see what it looks like with the API. We'll be running vision classification on this hot dog. So we see here that I do import ModelZoo.sugar. This is a syntactic sugar package that we've written to help wrangle input and output. So I run inference, and we get back a table, same as we did on the site, and it says that it's 99% confident it's a hot dog. So that's pretty good, right? So let's contextualize. Simon and I are undergrads. And as an undergrad, you quickly learn that food is not cheap. Fortunately, we work at a lab that oftentimes has leftovers. So we want to make a service. We want to know when there's food in the lab. This weekend, we're going to sneak into the lab and install a camera in the kitchen. And we want to write an application that can take those images and tell us if there's food or not. The application is pretty simple, so it doesn't really matter that we're using ImageNet data. So we need to filter. We need to figure out what models are actually useful for this task, right? In this cell, I've written a really quick thing to filter the models that we'll find useful. And the predicate I filtered on is either ImageNet in the model's name or the model's category being vision classification. So I run this, and we see the 3 models we're going to run on. ResNet 152, ResNet 50, and ResNet 18. So let's run our models on some data, right? Let's see how it does. So first, we'll look at the data. It's a pretty standard picture of a cheeseburger, some guacamole, and some butternut squash. We define our data and our labels, and we run it. And we see this cool little progress bar, right? And we can see that our models do pretty well. So this is just listing the probability or the confidence that the model has in the correct label. They do pretty well on the first 2, not so great on the third one, right? So at this point, I've shown you how to use our programmatic API to query ModelZoo. And it didn't really take anything fancy. All we used, the fanciest thing we used was tq2m for that progress bar. But all we really used was a for loop and some imports from the ModelZoo API. So, going back to the story, Simon and I take a look at these results, and we decide an ensemble is the way to go. We want to take the 3 models, issue 3 queries to each of the models, combine the results, and normalize the probability. We try it out, and it goes so well that we want to share it with everyone else. So we're going to deploy it to the ModelZoo. So let's see what that's going to look like. First, we, this should actually be commented out. My bad, guys. Whoops, sorry. Okay, so first let's define the function. All this is going to do is query the 3 models we saw last time, combine the results, and normalize the probability. So let's test it out on this image. To be honest, I don't know what this is. If anyone does, feel free to correct me. So we run it. It takes an image. It takes some metadata. It runs. OK, we get back our output. So if you'll notice from before, we had, where is it? Our models each did the top 3 probabilities, right? So here, since we're doing all 3 and combining them, we have 9 results. And it looks like corn is the one it has the most confidence in, which kind of makes sense, because the row looks like corn kernels, I suppose. Right, so now I have to deploy it to the ModelZoo API. What does that look like? All I gotta do, first though, we should probably discuss our uniform interface. All right, so if you'll remember, I said that one of our goals was to create a uniform interface for model evaluation, right? And this image sort of talks about what we're trying to do with that. Basically in ModelZoo, we have 3 domains, image, text, and table. And each of them is represented by a wide variety of things. So an image can be an NP array, a pill image, a data URI, like a file name as a string, text is just a list of strings, and a table is a PD data frame. And ModelZoo has functions that automatically wrap and unwrap these values into like the gRPC messages and into your values, right? So to deploy my function to ModelZoo, all I have to do, well, to get it ready to deploy to ModelZoo, all I have to do is uncomment these 2 lines, right? And what these do is the first imports the register type decorator. And all that does is wrap your function in ModelZoo functions that will automatically convert the gRPC payload into an pill image and convert the table output into a gRPC payload. So after this, we'd have to go and deploy onto the back end. But fortunately, I've already done that. So the last step is to register the new model on the UI. So we go back to the UI. We go to register. We give it a fancy name. Let's say Rehan's ensemble. We specify the input and the output type. And like I said before, input and output type are decoupled. So it's basically a Cartesian product, right? Your model can take in any sort of input and it can take out any sort of output. Table is also a valid input type. It's just that we're still building that out in the UI. We specify the service type. So I know right now it only shows Clipper as a service type, but ModelZoo is actually backend agnostic. You can connect ModelZoo to anything, multiple things, in fact. It can be a RayServe cluster, it can be TensorFlow serving, it could be a Lambda function, whatever you really feel like. So I give the URL. This is just where my model is living, and I add some metadata. So let's say author, Rehan plus Simon, and I hit submit. All right, it's a success. Let's check it out. We see all the same models we saw before, and now we see Rehan's ensemble. So let's test it. Let's try with the cat. All right, and we see our big 9-input table, right? So basically what I've shown you is how to deploy a new model, right? Last, before we conclude, there's one model that Simon and Joey really, really wanted me to show you guys, and that is DeepMind BigYan 256. And the takeaway from this is sort of that input and output type really can be decoupled. So this is a generative model. It takes in a text input, and it returns an image that it generates corresponding to that text label, right? So let's try, I'm gonna go for it. All right, let's try Trump. Right, so you run it, and I don't know what this is. I think it's supposed to be a trumpet. I don't know how to describe this. I'm gonna be real with you guys. We try it again. All right, I know how to describe this even less. All right, try cat. All right, okay, I'm gonna be real. This is sort of nightmare-inducing, honestly. Some of these images are very nightmare-inducing. Yeah, no, I don't know what's going on here. Okay, all right. So back to slides. Basically, we have 3 goals with ModelZoo, and hopefully I've shown you how we implement all 3 of them. Just to recap, model discovery and sharing through the UI, which gives you visual acuity, a programmatic API through our Python ModelZoo package, and a uniform interface through all the different code that we've written, right? Thank you so much for your time. There is a survey that they'd like you to take to give us feedback, and if anyone has any questions, Simon and I can both take them about anything we've seen so far. Thanks. Yeah. What's up, Jerry? Yes. Do we really have the domain ModelZoo.live? And the answer is yes. I forgot to mention this, but if you go to https://ModelZoo.live, you can try everything I did and more. Yeah. Kurt. so that's actually a really great question. Sorry, did you have? All right. Yeah.
Can you repeat the question?
So yeah, I will repeat the question. So basically, Kirk likened this to like a model store, like an app store, and you want to know what the pipeline looks like for having strangers, I suppose, deploy models onto your model store. And that's actually a pretty interesting question. And I really have two parts of, there's like two answers kind of that I want to give. So the first is ModelZoo is sort of intended to be deployed within your firewall, right? So ideally, let's say you work at a big company, which, well, I suppose is very relatable for most of you. So let's say you work for a big company, right? There's multiple organizations, and a lot of organizations are solving the same sort of problems, but they don't really know that, do they? So having a ModelZoo instance within your firewall means that your engineers can be uploading solutions and sharing them across the organization. So you don't really have to be concerned with people deploying maybe malicious code, right? At the same time, though, you do raise a valid point. We do need some sort of pipeline, and this is something that Simon and I are currently engineering. So we use a token system to rate limit as well as prevent access to who can upload models. But we'd love for you guys to talk to us and tell us more about what you think is the right way to go with this.
And just in addition to that, ModelZoo Live is fully open source. You can search it on GitHub. And one additional thing is a single binary that can just be deployed on your own anywhere. Right.
So for this one, we're actually, okay. So like, as I said before, it's small, it's backend agnostic. For this specific tutorial, we're using a toy backend that's just a simple Flash server running a Python app. But have we tested it?
We can use Clipper, like, and reserve, TensorFlow for serving on like runtime. And so ModelZoo Live really lives on top of prediction serving system. Right. Thank you.
So to sort of address that as well, so if you look at register over here, when you select a service type, you have to give a URL basically. And so the middleware is in Go, so all the Go middleware does is query this with the correct query format, right? So at this point, you can really plug in anything you want, like even a Lambda function.
All right. Thank you, everyone.
Yeah. All right. Thanks.
All right, show the demo slide.
The demo slide.
The survey slide. Right.